Hi there, this is Mr. Alexander, and in this video I'm going to show you how to calculate z-score probabilities using the calculator, the TI-83 Plus and TI-84 Plus, and I'm going to emphasize the perils of doing so. So if there is ever an example of when you should default to what your teacher has taught you first, this is an example. Always do it by hand first. Use what I'm about to show you to double check your work. Let's just walk through this whole thing together and talk about it as in-depth as possible. Last year, a lot of Mr. Alexander's OnRamps stats students received a wake-up call on problem set 1. Out of 30 points, the average was 15.5 with a standard deviation of 6.6. This is all just made up. This is meant to be frightening. It wasn't actually this bad. By the end of Unit 4, you'll want your college grade to be above a 70%. 70% on problem sets is 21 points. What's the z-score for somebody who got exactly 21 points? Well, z is just x minus mu divided by sigma, mean standard deviation. So if you got exactly 21 points, then you would be, at least in my made-up class here, out of 6.6, that z-score is 21 minus 15.5 divided by 6.6. 0.8333, going out forever. All right. Couple things I want to mention on that is you'll notice that I did the entire numerator first, hit enter, divided by the entire denominator. You could have entered all of that in one keystroke by using parentheses, 21 minus 15.5 divided by 6.6. Just in general, if you're going to do it that way, good practice is to put the entire numerator in parentheses and the entire denominator in parentheses. I didn't do that in the denominator this time because there's only one thing down there. But if there's more than one thing, put the whole denominator in parentheses. Okay, so if we got a z-score of negative 1.5, and I want to know how many points they got on the problem set, then I'm solving something like this. And so what we'll want to do is multiply by 6.6 and then add 15.5. So what they got on the problem set then, negative 1.5 times 6.6 plus 15.5. They got a 5.6 out of 30, which is not great, but that's how you do it. What I really want to show you now is how to calculate proportions, because this is a powerful way to double check your work, but let's first review how to do it by hand. First off, what proportion of last year's OnRamps stats class received 21 or higher on problem set 1? So 21 or higher is a z-score of 0.83333333333333. To answer that, you've got to use these statistical tables. So I'm going to my statistical table, and I'm looking for 0.83333. Well, I've got a 0.3 and a 0.04. Which one do I use? You always want to round down if it's less than 0.5, round up if it's greater. So in this case, it's 0.3, 0.03, 3333. So we're going to round down to 0.03. The probability here, 0.83333. We're going to use 0.7967. So the probability, according to the table, is 0.7967. But that probability is always to the left. I wanted higher, so I'm going to do 1 minus that. The answer that I would want to type into, like the homework or something like that, is 0.20333. That's what I got from the table, and this is what I want to type into the computer if I was doing this on Canvas for homework or something like that. But maybe I'm not sure about that answer because these tables are a little convoluted. It's like, okay, stuff to the left, And I had to do some rounding in there, weird stuff. Let me show you a way so that you feel a little bit better about your answer. So there's a way not to double check on the calculator, but to get an idea of a pretty good answer. So I guess that's double checking. I should say what I'm about to show you is not a way to get the primary answer, not the thing you're going to type into the computer, but what I'm about to show you is a way to feel good about what you typed into the computer. So what I'm going to do is second vars, which gets me to distribution, and we're going to use normal CDF. And the TI-84s, this is really simple because you just put in your lower and upper bounds, your mean and your standard deviation, and you hit enter. A little bit more complicated than the TI-83. I'll show you that in just a second. But the lower bound here is 21. Now it says or higher. So what's higher than 21? Well, in the calculator, that's infinity, which is 1E99. Let me show you that again. So I hit the 1 key, which is right here, and then I did second comma to get this E99. What this says is 1 with a bunch of zeros after it. It's the biggest number the calculator knows. What's the mean? Well, I told you that the average was 15.5 and standard deviation was 6.6. When I paste that in there, look at that answer. Really close to what we had on the table. But you know what? If you type that answer in the computer, like on the homework or something, it's going to count it wrong. But that's really close to what I got, and I'm feeling pretty good about it. So this is a nice way to double check your work. Well, let me show you how it's a little bit different on the 83, though. So when I do it on the 83, second distribution, normal CDF, it doesn't prompt me for any of these things. I have to remember lower, upper, mean, standard deviation. So the lower bound, again, is 21, and the upper bound is still 1e to the 99. The mean is still 15.5, and standard deviation is still 6.6. Same exact answer. The nice thing about the 84 is it prompts you for these things. But if you have an 83, you just need to remember lower, upper, mean, standard deviation. Let's work through a couple more so that you feel good about this. It says, what proportion of last year's OnRamps stats class received 10 points or less on problem set 1? So I need to get my z. I'm going to take that 10. I'm going to do 10 minus 15.5 over 6.6. 10 minus 15.5 divided by 6.6. And that's, hey, look at that, negative 0.8333. It's like I planned it or something. Now, here, same idea. Go into the chart. This time I'm dealing with negatives. 0.83333 is going to be this one right here, 0.2033. Now I don't need to subtract that one from 1 because it says or less. And again, this table says to the left. It's giving me the probability to the left. And less means to the left, so I should be good there. But I want to use the calculator to make sure I'm good. So I'm double check my answer. This is what I'm going to type in the computer. This is my answer. Let's make sure I did it correctly, though. So my lower bound was negative infinity, which is negative 1e99. The way I know that is because it said or less, lower. The lower bound is always going to be negative. Upper bound is 10. Mean and standard deviation are the same. And again, it's that 0.2023. So I'm feeling pretty good about that answer because it's pretty close. It's off by like 1/1000th. Not bad. All right, last one, and then we're done here. What proportion of last year's class received between 7 and 18 points? The only thing you would do different here is that lower and upper bound, there's no infinity there. It's just 7 and 18. So this one is 0.5487. And let's see how far that would be off if I had done it by hand. So I need the z for 7, which is 7 minus 15.5 over 6.6. which is negative 1.287878. And then the z for 18, which is 18 minus 15.5 divided by 6.6 is 0.37878. So I'm looking up these probabilities here. I'm going to look up negative 1.29, because that 7 is going to kick it up to a 9. Negative 1.29 is going to be 0.0985. And then this one is going to be 0.38, because that 8 is going to kick up that 7 to an 8. So 0.38 is 0.648. Now, to get the probability that it's between these, this is to the left, so that 7 is to the left, and this 18 is to the left. To get just this stuff, I just need to subtract them. So it's simply 0.648 minus 0.0985, and hopefully that's pretty close to my 5487. 0.648 minus 0.0985. Pretty dang close, but still not quite the same. This is the answer, 0.5495. That's the one you're going to want to type in. But hey, I'm feeling pretty good about it. That is pretty close. So that's how you double check, and I can't stress that enough, double check the answer you get by hand. Always default to these tables. These tables are going to give you the right answer. The calculator is going to make you feel good. All right, that's it. Thanks for watching. See you on the next one.